This is the notes for 2.1 theoretical probability. Our definition says that the probability of the event is the number of ways the event can occur divided by the total number of equal likely outcomes. Okay, so you'll notice this is the same as experimental. So if you're reading this and thinking, I've seen this before, it's because you have. The last couple days when we're doing experimental, the only difference was instead of saying this word outcome, they said trials. So let's write that over here to the side. So experimental probability is when you actually do the experiment. So they use the word trials. Okay, that's the only difference in our definition. Outcomes means if I did this an infinite number of times, what do you hypothetically think should be my probability? Okay, so we're not going to actually do the experiment here. We're making an educated guess of what you think it should be. When we flipped a coin, theoretically, it should be 50-50. But when we did the experiment, let's say we did 20 trials, the odds of us getting exactly 50-50, right, weren't exactly true. So experimental is when you do it. Theoretical is if I did it an infinite number of times, what do you think it should be? Okay, so if I roll a 4 on a dice, there are 6 sides to the dice. The odds are, if I did it a long time, it would get really close to 1 out of every 6 times. I have 1 4 on my 6-sided dice, so the odds of it happening would be 1 out of the total number of outcomes is 6. Okay, if you did the experiment, maybe I rolled the dice 3 times, 5 times, 10 times. It's not going to always be this 6, but hopefully it's a fraction. Then at the end, I would simplify and be close to 1/6. In my calculator, then we need to do 1 divided by 6 to change that into a decimal and percent as well. Okay, so we're looking at 1 divided by 6. My probability is 16.6% repeating. What if I wanted something bigger than 2 though? So now I have some options. I could roll a 3, a 4, a 5, or a 6. So something greater than 2, I would have 4 possible options, but again, out of 6 outcomes. So if you did the trial, I could do this 50 times, 100 times. This could keep being different depending on the person and their number of trials. Theoretically, though, it should simplify to something close to 67%. Okay, so as many times you did the trial, hopefully you would get to something close to there. So I'm going to write down this is 0.6%. Remember, this is a 6 followed by another 6, so that is repeating. And then you can round it up and say 67% if you want, or you could do 66.6 with that bar again. Either way works. Okay. All right, here's where it gets a little tricky. I have 5 red, 7 green, 4 black, 3 orange marbles in my bag. My first step in these types of problems is to find the total. Right? If I'm supposed to make a fraction, where it's the total number of likely outcomes, I need to know how many options I have to start off with. So if I do 5 plus 7 is 12, plus 4 is 16, plus 3, right now I have 19 marbles in my bag. Okay. So look at specifically then, what are my options of drawing a green? In my directions, it said I had 7 green marbles, and then out of my total would be 19. Again, with my calculator, I'm going to do 7 divided by 19. We're looking at about 37%. So 0.368. I would round this 8, would round up my 6 to a 7, and I would say about 37%. Again, this is an approximation. We're not actually doing the trial for experimental probability. Theoretical is that if I did this enough, hopefully I would get something close to 37%. Okay. If it says green or black, this time I get to add them together. So green or black would be 7 plus 4. I would have 11 possible outcomes. Okay, so if it's one or the other, I can add together those choices, and then it's out of my total 19 again. So 11 divided by 19. We're looking at 58 when I round it up. So I can write down 0.578. When I move that decimal 2 places, you can just say 58%. You don't have to write down more decimals than that. Okay. So that was one or the other. I added them together. If it's anything other than green, then I'm going to add up all my other ones. So I had 3 orange, 5 red. I'll just make a note down here. And 4 black, for a total of 9 plus 4 is 13. Sorry, 12. I'm a math teacher. 12 out of a total of 19. Okay, another strategy, I'm going to write down here below it, is if you have a long list of things, I wouldn't recommend necessarily adding up everything but that. I could do my total was 19 and then subtract my 7 green. Either way, I should have 12 possible outcomes. Okay, so it's up to you, depending on your situation, if you want to add everything else in that list, or you could just subtract. If it's not green, you could just subtract green from this total. Okay, so then we're looking for 12 out of 19 is 63%. Every time, make sure you write down your original fraction. So I had the number of ways that it could happen out of the total of possible options. And then we're changing that to a decimal first and then your percent. Okay, so make sure you show that work. Those are your notes.